Alright, I'm going to give you an example of how to graph an absolute value function. Remember from our notes, we had this expression with a, b, c, d as values that can take various numbers, and I've defined the vertex of this to be at negative c over b, comma d. I've also mentioned that if a is greater than 0, it opens up, and if a is less than 0, it opens down. And I should just remind you, we're dealing with linear functions, so these are going to be V-shaped functions because of the absolute value. There's two different methods. One is use the vertex and opening direction, then plot points by choosing some x values and determining the y values. Pretty straightforward. Another method is to use the vertex, and the direction of opening isn't even as important, but we'll change the absolute value into piecewise functions. So I'm going to run through an example of what that looks like. And remember, we define the vertex by the b, c, and x. And so to change to piecewise functions, we're considering positive values of that, which leads to x greater than equal negative c over b, in which case we just graph the function without the absolute value bracket. And for other parts of the domain, the value is less than negative c over b, we graph the signed opposite. That's how we break it into pieces. So let's have a look at this example here. Okay, first of all, we recognize that it opens down because of the negative. Also, the vertex will be located at negative 3, comma 2. Okay. So in the first method, what I can do is I can plot some values by choosing the vertex. That's a good place to start. That's sort of the center of action. So notice I put it in the middle of the table of values. I'm going to choose a couple of x values smaller. I'm going to choose a couple of x values larger. Well, you can choose 0. Alright, and I'm just going to substitute these values in here. So negative 2, add 3 makes 1. Absolute value is 1. Multiply by negative 2, that makes negative 2, and then add 2. Well, that's 0. Okay, at negative 1, we'll substitute that in here. This makes 2. Multiplying by that makes negative 4. Add 2 is negative 2. And with 0, I get 3. Absolute value is 3. Multiplied negative 2 is negative 6. Add 2, that's negative 4. Go in the other direction. Negative 4 substituted in here makes negative 4 plus 3 or negative 1. Absolute value is 1. Times negative 2 is negative 2. Add this, I get 0 again. And at 5, negative 5 rather, I'm going to get negative 2. Absolute value of that is 2. That becomes negative 4. Add 2. Negative 2. We should see some symmetry in the table of values. Let's plot these. 1, 2, 3, 4, 5, negative 2, negative 4, 0, negative 3, positive 2, negative 2, 0, negative 1, negative 2, and I'm not even going to bother with 0, 4 because I can see the shape quite well now. And you would use a ruler, but for speed I just did it freehand. There's my shape. That's the first method. There's an absolute value. Let's look at the other method. In the other method, I consider values where xn3 is greater than or equal 0. So x is, actually I'll write it here, x is greater than or equal negative 3. Right? Now for that area, I have a positive value for the absolute value. So it's not even needed. I'll just replace it with regular brackets. Let's simplify that. Negative 2x, negative 6 add 2 is negative 4. So there's one line. And let's see, negative 4, right there. A slope of negative 2 means go down 2, which is off the screen, and right 1, or I can go up 2 and left 1, up 2, left 1, up 2, left 1, up 2, left 1, etc. Now don't forget, the domain was greater than or equal to negative 3. So negative 1, negative 2, negative 3. So from here, greater than. Now don't get confused by the fact that I'm going down. It's x greater than or equal to negative 3. So I'm not going to use this point at all. Okay, it was out of my domain. Now, the other part of the domain are values less than negative 3. Looking back at the original absolute value, see for values less than negative 3, the content of this is negative. So what I do is I replace this with the signed opposite, so now it becomes positive 2. Okay, I'll simplify that. I get 2x, this is 6, and 2 more is 8. So I'm going to plot, let me see, 1, 2, 3, 4, 5, 6, 7, oopsie, it's right up in my equation. And the slope is 2. Well, I'm going to go down to left 1, down to left 1, down to left 1. Should be no surprise that I end up at the vertex. Down to left 1, down to left 1, and let's connect those dots because I wanted only the values less than negative 3. Here's negative 3, less than, this direction. And you'll notice I got the same absolute value. Two different methods.